Hey everyone, I'm David Ramirez from Mexico, and I will present to you the rational functions with the example of American football. First of all, it's important for us to know one thing, and that's what rational functions are. A rational function basically is the division of two polynomials. Like this, we have m of x over n of x. As I told you in the beginning of the video, I'm trying to explain rational functions with American football. So first, you need to know the basic rules of American football. This guy right here is the running back. He gets the ball pretty often, and his basic job is to get a touchdown or a score. And these two guys right here are the wide receivers. His job is to run a route and catch the ball, and oftenly they make a touchdown. And the last guys right here are the linebackers. They are defenders, and their basic job is to tackle the guy that has the ball. They need to stop them from having a touchdown. So the offensive guys, the running back and the wide receiver, must avoid the linebackers. Now I'm going to explain the rational function basic rules and steps. The first step is you need to identify if it is a rational function or not. The next step is getting the vertical asymptote. The third basic rule is to get the horizontal asymptote. We have three rules. The first rule is that if the highest exponent of the denominator is equal to the highest exponent of the denominator, your horizontal asymptote will be the leading coefficient. In this case, we have 2x plus 3 over x minus 4. So the highest exponent would be 1 here and 1 here. They are the same, so now we are going to use the leading coefficient, which is 2. So the horizontal asymptote would be 2. The second rule of how to get an horizontal asymptote is if the highest exponent of your numerator is smaller than the highest exponent of your denominator, your horizontal asymptote will be 0. And the last rule of how to get your horizontal asymptote is if the highest exponent of your numerator is greater than your highest exponent in your denominator, then we don't have no horizontal asymptote. And the fourth step is getting the behavior. And the behavior is pretty easy to get. You have your original rational function and your vertical asymptote. You must have the vertical asymptote in order to get the behavior. Your vertical asymptote in this case is 2. So you need to get the closest two numbers of 2. In this case it's 1.9 and 2.1. These values must be substituted in your original rational function. So we will have and you don't have to do it all. You just need to get if it is a positive or a negative sign. Okay? The result of this one would be a positive, obviously. And you put the sign. The result of this one will also be a positive. So the behavior of this one would be positive. And you must do it with the other number, and if you have two vertical asymptotes, you must do it with 4 numbers, etc. Now I'm going to show you the relation between football, American football, and rational functions. We have already saw some basic rules of football and some basic but very important rules of rational functions. Sometimes in a rational function you will get a middle graph that will go like a cubic or a quadratic, okay? In this case, his relationship with football would be the running back. He's in charge to get the ball and score, and usually it's to the front. He never runs backwards. And manipulation would be the behavior. The behavior sometimes will give you something like this or something like this. Okay, and there are some routes that are run by wide receivers in football in order to catch the ball. So we would say the behavior is a lot of alike to wide receivers. And the most important, the vertical asymptotes. Vertical asymptotes can't be touched by the graph. It's almost illegal if your graph touches the vertical asymptote. So it will be almost illegal if the wide receivers and the running back touch the linebacker. So the vertical asymptote can be considered a linebacker. And now I will put some images so you can remember what I have just explained. Now it's time to graph with some football basic concepts. We have the f of x. It is a rational function, so let's start graphing it. The first step to graph a rational function is to get the x-intercept. And in order to get the x-intercept, we must change f of x to 0. So it would be. And what would happen? This would multiply with this and would be eliminated. So we would only take the numerator to get the x-intercept. So we have this. The second step will be get the y-intercept. And in order to get the y-intercept, we must make x value 0 in your original rational function. So we will have the third step is getting the vertical asymptote. Remember, the vertical asymptote will be taken with the denominator. So we have this. Equals 0, sorry. So we need to change the signs. And now the horizontal asymptote. Remember the rules? And the fifth and last step before we graph is getting the behavior. Remember, to get the behavior you need your vertical asymptotes. In this case, it's 3 and minus 1. Now it's time to graph with football. But now it's time to do the fun part. What does rational function have to do with football? We have here our linebackers, which are the vertical asymptotes, okay? And then we have this middle graph, which would be for the running back, because he avoids the linebackers and run, touch the intercept, pass the horizontal, and score a touchdown, okay? And then, and finally, we have our wide receivers, and they will run their routes to the outside of the field. So now let's take a closer look of what a football rational graph would look like. We have there a linebacker in the horizontal, in the vertical asymptote, another linebacker in the other vertical asymptote. We have our wide receiver, which runs with the behavior until the horizontal asymptote, his route to the outside. We have a running back who runs and touches the X and Y intercepts, and he would avoid the linebacker and score a touchdown. He goes upwards to the infinity, okay? And finally we have another wide receiver who continues his route to the outside, and that will be your final graph. Thank you guys for watching. It has been an amazing video, and thank you for the opportunity. Hello world.